Section 7.1 Graphing equation of lines and linear models. Solution satisfy and solution set of an equation in two variables. Definition: an ordered pair A and B is a solution of an equation in x and y if the equation becomes a true statement when A is substitute for x and B is substitute for y. We say that A and B satisfy the equation, and the solution set of an equation is the set of all solutions of the equation. First, we need to look at it linear equation. Linear equation is talking about a straight line in here. And x and y, this is a two variable. And we say if we do have the ordered pair, A and B is a solution of this equation. When you plug in A for your x and plug in your B for your y, and we got the true statement, then we say A and B, the ordered pair, is a solution of these equations. So let's try an example. It's an ordered pair 2 and 1, a solution of the linear equation. So you can see I have a y equal to 3x minus 5 in here. So this is a linear equation. If we want to check out if this ordered pair is a solution of this equation, we just need to plug it in. So we're gonna substitute 2 for the x and 1 for the y in the equation. So first, write it down. This is my original equation. Now we're gonna plug in x equal to 2 and y equal to 1. I put the question mark here because I need to show that if this is gonna be a true statement. Right now, I'm not sure if they are equal to each other. So that's why I put the question mark in here. Now, we do the math here. 3 times 2, that will be equal to 6. Okay, 6 minus 5, that will be equal to 1. Okay, so 1 equal to 1, is it a true statement? Yes, right? So we're gonna say 2 and 1 is a solution of this equation. When you guys working on the homework or chapter exam, make sure you answer the question. Don't just stop at here. Let me know if this ordered pair is a solution of the equation. Okay, number 2 is the ordered pair 4 and 9 a solution of this equation. I want you guys try to do it by yourself. Substitute 4 and 9 into this linear equation and answer the question. Tell me if this ordered pair is a solution of this equation. So plug in x equal to 4, y equal to 9 into this equation. Okay, check your work. Y equal to 9, x equal to 4. So 3 times 4, you got the 12. 12 minus 5 equal to 7. And 9 is not equal to 7. So this is a false statement. Again, don't stop here. Answer my question. Is this ordered pair a solution of the equation? No, right? So we're gonna say 4 and 9 is not a solution of this linear equation. Okay, graph. The graph of an equation in two variables is the set of points that correspond to all solutions of the equation. So we do have the notes in here. For number 1, any point that is a solution of the equation must be on the graph. Okay, so this is talking about like this example. I know 2 and 1 is a solution of this equation. If we could find more ordered pairs and is also a solution of this equation, then all these coordinates will be on the same line here. So this means any point that's a solution of the equation must be on the graph, on the same straight line here. And then Any point on the graph must be a solution of the equation. So if we look at the graph here, we find out all the points on the line here. That will be also a solution of this equation. So we're gonna use this idea. Try to graph the linear equation. Example, find 5 solutions of y equal to x minus 1 and put them in the same coordinate system. So I have this linear equation. You could make up any x or any y and then plug it into the equation and find out the coordinate. It doesn't matter what number you plug it in, and you're gonna make up the value for the x or you're gonna make up the value for the y. But look at the equation here. It will be easier if you make up the number for the x in here. And we're gonna choose the easy or small number. So the easiest way, I'm gonna pick 0, 1, 2. Okay, one more time. You don't have to plug in 0, 1, 2 here. You could put like -1, 0, or 3, or 3, 4, 5, or even 8, 9, 10. Doesn't matter. As long as you make up a value, you plug into the equation, figure out what is the y here, you're gonna get the order pair. So now we're gonna do it like one by one. When x equal to 0, plug in here. What is y equal to? So when x equal to 0, 2 times 0, that'll be 0. 0 minus 1, that'll be -1. So I do have a 0, comma, -1. So I'm gonna write it down on my table, -1. And this is gonna be my order pairs. Okay, try number 2 and number 3 also. Plug in x equal to 1, figure out what is the y, and write it in the order pair. Okay, you should get 1, 1. And then next one, you should get 2 and 3. Okay, we already have 3 points in here. Actually, when you want to graph the equation, you only need 3 points. Okay, you only need 3 points. But for this example, they want you guys find out 5 solutions. We only have 3 of them. So let me add 2 more. And then you could make up any numbers for the x again. But for here, I'm gonna make up -2 and -1 for the x. And again, plug into this equation. Figure out what is your y here. And then write it as an order pair. Okay, you should got this. Right now, we do have a 5 solution for this linear equation. Now we try to plug in these 5 order pairs into the coordinate system. So write down that this is my linear equation, and I have this table here. Okay, I have the coordinate system here. I have my x-axis, y-axis, and then I'm gonna do it one by one. When x equal to 0, y equal to -1. So x equal to 0, y equal to -1, we do have this point. And x equal to 1, y equal to 1. So go to the right 1 unit, go up 1 unit. So you have a 1, 1 in here. And then 2, 3. So go to the right 2 units, go up 3 units. Same idea with this 2. So you could see we could connect these 5 points together and get a straight line. Okay, that will be a straight line pass through these 5 points together. So means these 5 order pairs is a solution of this linear equation. Okay, graph of y equal to mx plus b. Okay, the graph of an equation of the form y equal to mx plus b, where m and b are constant, is a line. Sketch the graph for this equation. Also, find the y-intercept. Remember what is the y-intercept? When your linear equation hitting the y-axis at that point, that's called the y-intercept. Calculate three solutions of this linear equation in the table. Then put the three corresponding points and sketch the line through them. So I have this equation here, and I try to make up the values for the x. So I'll have the x. I'm gonna put x equal to 0, 1, and 2. Okay, I want you guys do it by yourself. Plug it in here. Tell me what you guys get for your y. Okay, check your work. When x equal to 0, plug it in. So negative 2 times 0 plus 3. So that'll be 3. When x equal to 1, plug it in. So y equal to 1 here. Okay, so right now you do have a three order pair. 0, 3, 1, 1, 2, negative 1. I want you guys put these 3 points into the coordinate systems and try to connect it with the straight line. Okay, you should have the pictures looks like this. I have 3 points here, 0, 3, 1, 1, 2, and negative 1. You could see I could connect it with the straight line here. Okay, now figure out what is your y-intercept. Y-intercept means when the linear equation hitting the y-axis in here and this point, right? So this is called 0, 3. So y-intercept is going to be 0, 3. Okay, the meaning of b for an equation of the form y equal to mx plus b. So we already used 2 examples. Try to graph the linear equation with the form y equal to mx plus b. But what does the b means in here? Think about it. The earlier example, we do have the equation y equal to negative 2x plus 3. And we have the y-intercept, 0, 3 here. And then we have another equation, y equal to 3 over 2x minus 2, and has a y-intercept negative 2. Think about it. What is the meaning of b in here? So like here, when I have a y equal to negative 2x plus 3, I have a plus 3 here. And then my y-intercept will be equal to 0, 3. Okay, another one, y equal to 3 over 2x minus 2. So I have a negative 2 here. My y-intercept, that will be 0, comma, negative 2. Did you guys see that? So you know what is the b here? When we have the equation y to the form like y equal to mx plus b, when we substitute x equal to 0, okay, when we put x equal to 0, we're gonna find it out y equal to b. And remember how to find the y-intercept? If we want to find y-intercept, x has to be equal to 0. Okay, so right now we plug in x equal to 0 here, y equal to b. So that means y-intercept, that is equal to 0, comma b. So next time, when I give you guys the equation in this form, y equal to mx plus b, you could just tell me what is your y-intercept. Okay, remember this form, y equal to mx plus b. The b here stands for y-intercept. Y did in a coordinate, so that will be 0, comma b. That's a y-intercept. And the m here, so this is talking about the slope. So look at this equation, y equal to mx plus b. So my slope for this equation will be -2. For this one, y equal to 3 over 2x minus 2. So my slope here, that will be equal to 3 over 2. M equal to 3 over 2. Okay, equation for the horizontal and vertical lines. If a and b are constant, then the graph of y equal to b is a horizontal line. So you can see when you have the equation, there's a no x in here. Okay, there's a no x in here, and b is a constant. Y equal to b, we call this is gonna be the horizontal line. So means I have a horizontal line hitting b on your y-axis. And if you have the graph of x equal to a, there's a no y in here and a is a constant, then this is gonna be the vertical line. Okay, means I have the vertical line pass through the a on the x-axis. Okay, try this example. Sketch the graph of y equal to 3. Remember we say this is a no x in here and 3 is a constant. So y equal to 3 is a horizontal or vertical? Look at here. It's a horizontal line, right? So that means y equal to 3 will be horizontal line pass through to the 3, hitting the y-axis. We still can use the table. Okay, we're gonna make up all the values for the x in here, figure out what is your y. Think about it. When x equal to -2, if I plug in here, do I have an x in here? No, right? So when x equal to -2, y equal to 3. When x equal to -1, since I don't have the x in here, so y is also equal to 3. So based on here, these 5 order pairs, you're gonna see that will be a horizontal line. Of course, when you guys working on the chapter exam, you could skip like this table. Okay, I just showed it to you guys why this is gonna be horizontal line. You need to remember that y equal to a constant, that will be horizontal line hitting at that point. Okay, next one. Sketch the graph of x equal to 2. Again, x equal to 2, that's a no variable of y here. Means no matter what you put for the y here, x still equal to 2. So that's why we do have a vertical line here pass through to the 2. Okay, equation. Whose graph aligns? If an equation can be put into the form y equal to mx plus b or x equal to a. Okay, y equal to mx plus b or x equal to a. We just talked about this one, right? X equal to a, this is a vertical line here. Where m, a, and b are constants, then the graph of the equation is a straight line. And we call such an equation a linear equation in two variables. So remember this y equal to mx plus b. I have a two variables in here. And this is going to be the linear equation. Linear equation means there's a straight line here. And you may ask, hey, how about this one? I only have a one variable in here. And actually, this is also the linear equation. We just consider the constant of the y in here, that will be equal to 0. So that's why we don't have the variable of y. Okay, rule of 4 for solution of an equation. We can describe some or all of the solution of an equation with, first one, an equation symbolically. Number 2, a table numerically. Number 3, a graph graphically. or worse, verbally. So we call this is going to be the 4 ways to describe the solution and no one has the rule of 4. Okay, example. Describe the solution by using the rule of 4. Number 1, list some solution of y equal to 4x by using a table. So here, I want you guys get a table here and then just make up the value of x. And then figure out what is my y here. So in this one, I'm gonna make an easy number. I will do -1, 0, and 1. Plug it in to the equation. Tell me what did you guys get for your y. So plug into this equation. When x equal to -1, you're gonna get -4. When x equal to 0, y equal to 0. When x equal to 1, y equal to 4. So this is gonna be list the 3 solutions in the table. And then number 2, describe the solution of y equal to 4x by using a graph. So we already have a 3 order pairs and I want you guys plug into the rectangular coordinate system and connect it with the straight line. Collect all these 3 points using a straight line. So you should have the pictures like this. Okay, I have a 3 order pairs and you could join these 3 points together with a straight line. Okay, describe the solution of y equal to 4x by using words. So we just say for each solution here, y coordinate is equal to 4 times the x coordinate. Okay, graphing an equation of a linear model. A researcher recorded the weights at which a cracker traps for various temperatures. A random selection of the data is shown in the table below. Let R be the trap's weight, the number of traps per 13 seconds, when the temperature is F degrees Fahrenheit. Identify the explanatory and the response variable. So look at the table here. We have the temperature here, and we have the trap weight in here. So which one is gonna be your explanatory variable? Which one will be your response variable? You could think about it, the trap weight here, it depends on your temperature. When you have the 81 Fahrenheit, really hot, they will have a higher trap weight in here. When you have a lower temperature like 57 Fahrenheit, then the trap weight is only like 18. So the trap weight here, it depends on the temperature. So you could think about it, the temperature here, that will be your explanatory variable. And the trap weight here, that will be your response variable. It all depends on the temperature. Okay, B, construct a scatter plot by hand. So I have the coordinate here. This is represent your explanatory variable. That will be on your x-axis. The trap weight here, this is going to be your response variable. That will be on your y-axis. So I have the coordinate 57, 18, 73, and 36. So construct the scatter plot. Make sure you have the title, label the x-axis, and label the y-axis. You should have the pictures like this. Okay, on your x-axis, that will be your temperature in Fahrenheit. And then the y-axis here, that will be the trap weight here. So the first coordinate here, this is going to be 57 and 18. 57 like here, and then 18 like here. Okay, so put the coordinates in here. C. Is the association positive, negative, or neither? What does that mean in this situation? Remember the chapter 6, session 6.1, we learned about the linear association. The positive, negative, it depends on the slope. So look at the scatter plot here. You could see all the points like going on like this way, going on like this direction. Means when they increase of the temperature, they're gonna increase the trap weight here also. So this is gonna be the positive slope, okay? Positive slope. And also, we could draw a straight line here. And all the points is gonna be around the straight line. So we could say there is a positive association. And that means in general, as the temperature increased, the trap weight of the crackers also increased. Okay, D, graph the model. I have the model. This is a linear equation, right? Just like y equal to mx plus b. So you know this is going to be a straight line. By hand, on the scatter plot, does the line come close to the data points? So I want you guys graph the linear equation on the scatter plot here. Remember how to do that? We're going to make up some points for the f in here. And then plug into the linear equation, figure out what is your R, what is the weight in here. So you could make up anything. I would try to make up the numbers within from 50 to 85. You could pick any numbers from 50 to 85 for your Fahrenheit. So I will make it like 50. So plug it in 50 into this equation. Okay, so I will have R equal to 1.02 times 50 minus 38.03. Use the calculator, you're gonna get 12.97. Okay, second one, I'm gonna use a 60. Plug it in, use the calculator, you're gonna get 23.17. Okay, last one, let me make it like 80 because I want to draw the straight line from here. 80, plug it in. You should get 43.57. So I have a 50, the coordinate 50 and 12.97. So it's about like 13, right? 13 is gonna be somewhere like in the middle here. So like this point. And then 60 and 23.17. So 23 somewhere like here. Okay, I have a second point in here. Last one, 80 and 43.57. So it's about like 44, close to 44 like here. Okay, so I have these 3 points here and join these 3 points with the straight line. You could get the graph like this. Okay, does the line come close to the data points? Is the points is really close to this straight line? Yes, right? The model comes close to the data points. So means like there is a strong positive linear correlation. Okay, we say strong means all the points is really close to the straight line in here. Use the model to predict the trap weight when the temperature is 70 Fahrenheit. So means like I want to plug in F equal to 70 and find out what is the R. Okay, the model here, this is talking about the linear equation that we found it from here. I want to plug in F equal to 70. So actually you could look at this graph also. When F equal to 70, you're gonna go up heating the linear equation, go to the left. So that be somewhere like 33 or 34. Okay, try it with this linear equation. Plug it in, f equal to 70. Use the calculator. You should get 33.37. So according to the model talking about the linear equation, when the temperature is 70 Fahrenheit, the trip rate of the crackers will be about 33 trips every 13 seconds. That's it for the session 7.1.